Hello there. Let's have a look at Lab 3, Drawing with Functions. Because in Lab 2, you make a pretty picture. Maybe you made something like this, if you happen to do exactly the same thing. Which is nice, but video games generally don't just show one static picture all the time. The player will move around the screen, and so will the enemy. Maybe things change. So what would be nice is if we could change this program that makes this static picture so that it is more flexible, so that it can draw the snowman over here, or over here, or over here. Maybe it can make some new snowman enemies and have 4 or 5 or 10 of them. So we want to make this program flexible. And one way to do that is with functions. We can group these things. So rather than going from top to the bottom and doing all these things in order, we can make a recipe on how to draw a whole snowman, snow person. We can run that recipe as many times as we want. So let's all start with this code here. This is in the drawing with functions. I'm going to do this in Lab 3. So we can go to Lab 3, double click on it, and we've got an empty file here. And the starter code that we will use is this. So we can select it all, right click, copy, put that over there. Ooh, where's my code gone? There it is. And then right click, paste. I think it's nice to have it side by side if your screen is big enough for that. I'm just on a kind of small laptop and it fits for me, so hopefully it fits for you. And Paul Craven, who made this tutorial series, is claiming that this code makes this picture here. And we're going to convert it to be more flexible and run with functions. When you run code, most of the time, and I can tell you as a fairly experienced programmer, most of the time it fails. Most code fails. It generally fails. And you go through a process of running it, seeing what's wrong, trying to figure out what's wrong, and then once you've figured it out, trying some things to fix that, and then testing it, and then fixing, and then testing, and then fixing, and only moving on to the next thing when you're really confident that what you have now is well understood, you're happy with how it works, and you know that it works. So let's run this and test it. Okay, good, it works. If we read through the code, we can see we're using the arcade library in Python. We're going to set a variable called screen width, 800, screen height, 600, and make a window that is that width and that height. The title is drawing with functions. We're going to set the background color to blue, so it looks like that worked. The background set to blue. We're going to start rendering things on the screen. We're going to make a rectangle, telling the computer about the left, the right, the top, and the bottom. So 0 pixels from the left here. Screen width, which is 800 pixels on the right, so that's from all the way from left to right. Top. The bottom is at 0 down here, and the top of this light blue rectangle is 1/3 of the screen height. So 600, about 200 pixels high, about there. And the color is superiority blue, which sounds lovely. And then we draw the snow person. I like this code because it's got good comments. What do we need to do? Well, first we've got the code, and then we're going to make a main function that's going to do everything. So all of this stuff here, all of that is going to go in a function called main. So we're defining a function, making a function, defining a function, we're calling it main. To say that it's a function, we need brackets, because functions always have brackets. And then in Python, we've got these 2 dots here, a colon. Shift, semicolon button on your keyboard, get that symbol up. And we want all of this to run when we run the main function. So we go tab, and then we go here and go tab. And this is really tedious to do tab for all of these to show that these are all inside the function called main. So when we say, hey computer, do the main thing, it will run all of this code. To save you from having to do this process manually to show that it's inside the main function, you can just select it all and press tab. I'm going to skip something that they've got in their code just to show you what happens. Because this says I've given the computer like a recipe of this is how you do the main thing. You follow these steps. That's how you do the main thing. And I've given the computer the recipe. Press play. Nothing happens. How strange. The computer knows the main function now, but I haven't told it to do that thing. So at the end, I can say, okay, now run that recipe. Run that function. Main. Oh, there it is. Good. I didn't notice that. It came up down here. Yeah. So maybe that seems a bit silly for now because we're only running this thing once, hopefully, although I clicked the button too many times. But we're going to break the other things into functions as well. So we can have a recipe to draw a snow person, a recipe to draw the ground. I'll also put a little comment here to describe what this main does. This calls the main function to get the program started. So then someone reading my code will know what this does. Okay. This is really important. If it doesn't work, stop and get help. Continuing will only make the problem harder. Very, very important. Test your programs really often to make sure they're doing what you expect, even when they are not finished. In fact, especially when they are not finished. You need to test that it's doing what it is meant to do really, really often. Because if you have a mistake, like, I don't know, like this, and then it doesn't work, or a mistake like this, and it's in the wrong place, and you keep going and adding to your program, it's going to be really hard to find that bug later. So try to test your code often, and fix bugs or get help with bugs as they happen. So like I mentioned, we're going to break each of these into its own function. We're going to have a function, like a recipe of this is how you do this thing. We're going to teach the computer how you do a thing called draw grass. So draw grass is the name of the function, def space draw grass. I've got the brackets, I've got the smiley. And now this, draw the ground, will be in here. There is a suggestion here, or the way that it's done here, to use triple quotes, which I've mentioned can be used to make a big long string, but they're also used to describe a function. So that is something that you can do as well. So now the computer knows how to draw the grass. If I press play, it didn't actually do it though, because I need to tell the computer when I want it to draw the grass. I want to draw it once, right here. Okay. Does it seem kind of silly that we're putting all this work into changing our program to do something that does the same thing? Well, that's really common. We're changing it so that it will be easier to do better stuff later. So later, for example, we can very easily make lots of snowmen or snow people. Okay, so we've done that for grass. Let's do the same for snow person. So we've got a function here to draw a snow person. We can put a description, 3 double quotes, and a description of what it does. Draw a snow person. And now we're going to move, well, what is the snow person? It's got the snow and the eyes. So the the 3 big balls for the snow, big white balls, white circles, and the 2 little black dots for the eyes. That is how you draw a snow person. So now my main function starts to look a lot simpler. It's not as long, and short code is a lot easier to debug and fix. So now my main function will draw the grass and then draw the snow person. So much easier for someone to look at and figure out what it does. Okay, good. So just check that it does the same thing. All right. This draws the snowman only at one spot. I want to draw lots of snow people anywhere I put them. So to do that, we can make our function more flexible. So instead of just saying, draw a snow person, you can say, I want to draw a snow person at this position. To give the computer a position. We've got an X position and a Y position. So we will need an X and a Y. If you're drawing a picture, then it's common if you're using this arcade library to just add on the X to every X coordinate. So add it there, 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 and add a Y to every Y coordinate. There, 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 there. So you can draw a snow person at 50 pixels and 50 pixels. There we go. And there's our snow person. Now, in this demonstration, where's the dot? There we go. Just to make it easier to see where the snow person is, 50-50, I think, is going to be somewhere about here. Well, I kind of cheated because I looked at that dot there. But the snowman is not here. The snowman is all the way up there. And, oh, where are we? Where are we? Yeah, this says to draw the snowman at 50-50, but it actually draws it over there. Let's put a dot at 50-50. That will make life a lot easier. Let's do that. So here, whenever we draw a snow person, we can, before we start drawing, in the arcade library, there's a function called draw point. We need to tell it, oh, this is handy, the X position, or draw it at the X position of the snowman, and the Y position of the snowman. The color, arcade.color.red. And we'll draw it, the last thing is the size here, 5 pixels. There we go. So we're meant to draw the snowman here, but he goes all the way over there. And just to show you that this is a real problem, I'm going to draw another snowman at, I don't know, just further across, I guess. 200. And the same vertical position. See, this snowman is meant to be over here. And this snowman is meant to be over here. So you can see the X value is way, way too high. An easy way to fix that is just to subtract something off all of the X values. So maybe I'll subtract, I don't know, 100. We'll see what that does. Off of all of the X values. And I'll close it and run it again, see what it does. Is that enough? No, it's still too far to the right. Well, okay, let's subtract, I don't know, let's subtract 200. Maybe that might be too much. So that's going to be 0 now. This one, 185 take 200 is minus 15. And that is 15. So you can do a bit of trial and error to find the right. Oh, there we go. That is exactly in the center. So to find the right offset, I suppose, the right positions for the X and the Y. Do you notice that I changed them all at the same time and I subtracted the same thing from all of them? Let's see what happens if I just subtract 100 from some of these things. So now I'm going to adjust the Y. I know I'm too far up, so I need to move down and subtract off the Y coordinate. Oh, he got decapitated. Poor little snow person. So that's why it's important if you're going to subtract or add, and you want your picture you're making to be all together, just make sure you add or subtract the same amount from all of the coordinates here. All of the X coordinates, I mean, and all of the Y coordinates. I think it's still a little bit too high. I'm going to cheat a little bit. So they subtract off another 40, I think, from all of these. So just subtracting 40 from each of these. And now, yay! Perfect on the dot. Perfect on the dot. All right. Animating. Whew. So much stuff. So much stuff. I might put animating in the next one because now we've got our beautiful snowman and we can put snowmen all you know, different. Maybe I'll put this one a little bit higher, so the Y coordinate is a bit higher. And I'll put another one, you know, even further to the right and really low. And you can get as many snow people as you want. You can imagine this is really useful if you've got lots of enemies. All right, and then the next video, I will show you how to animate our snow people. Adios!